did domain, we talked about there being only two scenarios where you have to be careful with it. Otherwise, it's always all real numbers, right? So those two scenarios, again, were if you have a fraction or if you have a square root. So if you see one of those two things, or both of those two things, like we do in problem D, then you're going to have to figure it out. Otherwise, if it's anything else, like, for example, this one, what would the domain be here? Yeah, there's no fraction, there's no square root, so it's all real numbers. Same with this one. Let's see, any other stuff going on here? What about this one? What would the domain be? Yeah, there's no fraction, there's no square root, no problem. Okay? Let's go back to this last problem. So here we have both. We have both problems that we have to deal with. Let's start with the square root. When we have a square root, we are only allowed to take the square root if whatever is in the square root is 0 or higher, right? You can't square root a negative. So we start by saying that. We're going to go ahead and solve this like normal. So move the 1 over. Divide by 3. Okay. So the square root has this domain. But that's not all. We have a fraction. Okay? So what's the final piece here? What is the denominator never allowed to equal? Good. And so now we're going to go ahead and solve this again. Do you know what value makes this equal to 0? I mean, we already figured it out. The negative 1/3 is what makes it 0, right? So all we're going to do is just say, you know what? We don't want to include negative 1/3, so we're just going to make it greater than negative 1/3. And now we're okay. So then the domain would be x is greater than negative 1/3, which if you write in interval notation would be written like so. Okay? So if you see a fraction or square root, that's when you got to be careful with the domain. Otherwise, it's going to be all real numbers. Okay? For now. Eventually, we'll throw in more stuff, but not yet. Any questions before we move on? Okay, let's go to page 2. For today. So first, before we do difference quotients and then do a couple of other problems, we're going to talk about how you combine functions. In other words, how you add, subtract, multiply, and divide them. Okay? So you pretty much do what it looks like you would do. If we want to do f plus g of x, you are just going to add the two functions together. You're going to take f of x and g of x and combine like terms. When you're subtracting, if you do f minus g of x, similar. You just take the first function, subtract the second one, and then combine like terms. Okay? Same with multiplication. You just multiply them. If you're dividing, you divide them. Okay? So it's pretty straightforward. Let's do one more thing. Okay? When you're adding, when you're subtracting, and when you're multiplying, the domain is the intersection of the domains of f and g. So in other words, you kind of look at both domains for f and for g, and you kind of combine them into one domain. Kind of like what we did in this last problem here. We kind of looked at two separate functions. First, we looked at the square root, found that domain, and then we realized, hey, we have a fraction, so then we found that domain, and then we combined it for one final answer. Okay, so that's what we're going to do anytime we are adding, subtracting, or multiplying. When we're dividing, okay, it's the same thing, so it's still, the domain is still the intersection of domains for f and g, but the denominator cannot equal 0. So that's the only added piece there. When you divide, you can't divide by 0, so you have to kind of think about that as well. Okay? Let's see what else to add. Oh, final thing before we start doing some of these. A lot of times it's helpful for this scenario to find the domain before simplifying whenever you're doing a fraction, okay? Because a lot of times what's going to happen is that that domain or that fraction might end up looking like something else, but you still have to work off the original problem. Okay. Let's go ahead and find the domain first. So we're going to add, subtract, multiply, divide these, but let's find the domain for all four of these first so that we have them in front of us. Okay. What was the domain for this one again? Good. This one, what's the only problem here? Yeah, we have this denominator. It can't divide by 0, right? So we're just going to take, thank you, Philip. So we're going to take the denominator and figure out when it would equal 0. What x value do we not want to see here? 1, very good. So the domain, we have all real numbers for f, x not equal to 1 for g. Now we have the second one, we have a square root. Right, so how do we find the domain for a square root again? You guys got to keep up. This course is going to knock you out if you're not following.
Do we make it greater than or equal to 0?
What? Yes, what do we make greater than or equal to 0?
What's inside?
Perfect. And in this case, it's literally just x. So we don't have anything to solve for. That is our domain. Okay? Last one. What is the domain for j? Why? Yeah. There's no fraction, no square root. It's going to be all real numbers. Okay? All right. So with that in front of us, now let's go ahead and start talking about setting these up. So if we're doing f plus g of x, we're going to take f, which is 2x plus 1. Then we're going to add g, which was 5 over x minus 1 minus 2. Okay? And now we simplify this. So there's really nothing to distribute. We're just going to combine like terms if we see any. The 2x for now is good. Can I combine the 1 with anything? Positive 1 and negative 2 equals minus 1. And then we still have positive 5 over x minus 1. Okay? Now, I'm not sure on my math lab how far they want you to go. For me, this is okay. Okay? But I have a feeling that they might want you to combine and actually add the fractions together. So we might as well review that at least one time. So if we put this entire thing over 1, you guys remember how to add fractions together if the denominators are different? What do you have to do first? How do you add a half with a quarter? And then for 1/2 and 1/4, what would the common denominator be? It'd be 4, right? Because you can see 1/2 is the same as how many quarters? Think pieces of pie or pizza. 2/4 is the same as 1/2. Does that make sense? So when we have this, okay, even though we have variables, we can easily make this first fraction have the same denominator as that second one by just multiplying by that denominator. Okay, does that look familiar? Hope so. And now you're going to go ahead and distribute or FOIL, which you guys should be comfortable doing. X times 2x is 2x squared. X times the second thing, which is -1, is minus x. -1 times 2x is minus 2x. And then -1 times -1 is +1. And then we still got the second fraction, which we're just doing +5 from. And now that's all divided by x minus 1. Okay? When you add the two fractions together, you just put them into one fraction with the same denominator. Okay? Now, if there's any other simplifying we can do, we do that. It looks like we can at least combine like terms here. This will be 2x minus 3x plus 6 over x minus 1. And I don't see any factoring that we can do. 1 and 12, 2 and 6. Nope. So this is good. Okay. Now the domain, again, we're just combining the two domains from both f and from g. The domain for f was all real numbers. The domain for g, however, was x not equal to 1. So we're just going to say then that x cannot equal 1. Okay, so if we start with the entire number line and then we learn that x can't equal 1, then that's really the only problem that we have. Everything else is still going to work. Okay? Any questions on that? Okay, let's work through this one. What goes in the first parentheses? 2x plus 1 minus. Second one is just the square root of x. There are literally no like terms here. So we're essentially done. We can just lose the parentheses, distribute the negative, and this would be our answer. So this one's actually kind of nice because there's really no work to do. What's the domain going to be for this one? Good. Okay. F, all real numbers. Cool. H, however, has a greater than or equal to 0 domain, so we're going to use that one instead. Okay.
So if there's 2 and one of them is greater than or equal to 0, and the other one's not greater than or equal to 0, use that one.
Yeah, and so think of what the word intersection means. So imagine we have our number line, right? I think this will clarify if you're a little confused. The first domain was all real numbers, so that's literally, everything on the number line, right? And then the second domain was 0 or higher only. So if we do that one, let's say 0 is right here, then 0 or higher is over there. Do you guys see where the overlap is? The overlap is this piece right here where the two are on top of each other. So that's why we go with greater than or equal to 0. Does that make sense? Good question. Okay. Let's do...
Why would it be greater than or equal to? Wouldn't it just be greater than 0?
No, because you can put 0 in there. You can take the square root of 0,
yeah.
right? The only time you actually don't want to include 0 ever is if you have a denominator. Otherwise, 0 is going to be okay. Okay, let's go on to C. Now we're doing F times J. Why don't you guys do that one real quick? Start brushing up on those algebra skills. Busting out calculators already? So I'm going to start working through. You guys can check your work as I walk through it. So that'll be negative 8x squared. Did you guys get that? Negative 8x squared minus 20x minus 8?
Yeah.
Okay, good. What's the domain?
All numbers.
Is it ever going to be that we have to do that extra step and factor that? Or is it
Well, this would be what it is if we factor, we're just going to go back in a circle and do that. So, no, usually if you're simplifying, everything's multiplied out. Otherwise, factoring will show up in a different way. Okay? All right, this one's not too bad. Let's do this one. F divided by H. F divided by H. That's it. Can't really do much else. Okay? What's the domain?
greater than or equal to 0? Wait, no.
You're close.
It's greater than 0.
Just greater than 0.
0 because it is now.
Right, so it looks like it's greater than or equal to 0 because that's the original domain for the square root. But because we have it in the denominator, we just take that 0 out. So it's just higher than 0. Make sense?
Do we write it like that in the parentheses, or do we write it like x? Yeah.
Either way, you got to be comfortable with both. On an exam, I'm not going to care how you write it. Typically, I don't think we really say one way or the other. You could write in words, x is bigger than 0. That would be fine too. But on my math lab, it'll tell you, I think, use interval notation or write it as an inequality. So just make sure you follow that. Okay. Let's do E. Now, there's a couple ways that you can do E and a couple ways that you can do F. Okay, I'm going to show you what I think is the easiest way, which involves less work. So first, F minus G of 10, we have to recognize that that's the same thing as F of 10 minus G of 10. Okay? And now you should be able to figure out each one of these separately and just, subtract whatever those two answers are. Okay? So if I do F of 10, what do I get when I plug 10 into the equation for F? And then if I plug 10 into G, that's going to be a little bit trickier. So it'll be 5 over 10 minus 1 is going to be 9 minus 2. Okay, and yeah, if you have a calculator, I suppose, since this doesn't have any variables, you can just type all of that in and then convert it to a fraction. That's probably the fastest way to do it. What are you going to get when you do that? You guys know how to convert into a fraction on the calculator, right? Oh yeah, we did that in the probability unit at least.
I'm getting 166 over 9.
What is it?
I'm getting 166 over 9.
166 over 9. Okay. You guys try F real quick. It is multiplying. I thought it was subtraction. Thanks for catching that. So you should be getting -7. Okay? Any questions on that? All right. Let's go on to the last page. Examples, these last two examples are actually a little easier. We can do those at the end. But this is kind of, this right here, you guys, this is the toughest part of the section. It's not so much because it's hard, it's just that there's a lot of little steps along the way. And usually the more work there is, the easier it is to like lose a negative somewhere or make a little error. Okay, so you got to be really careful when you're doing these kinds of problems. So this right here is what we call a difference quotient. Okay, for those of you that will go on and maybe take calculus, you guys will see these quite a bit because they have the derivative is what this turns into eventually. Okay, so it's good that you guys get some exposure to this and learn how to simplify things that are difference quotients. Okay, so first I'm going to explain this one way. If you look at just this part, what does this mean to do?
FOIL f to x plus h.
It does not mean to FOIL. What if this had just said f of 5? What would you do with the 5? Plug it into the x, right? So even though this is a variable expression, you're going to take this and you're going to plug it into whatever the f is, whatever the x is for the f function. Does that make sense? Okay. So for example here, let me just write that out first. F of x plus h is going to be -3 times x plus h plus 7. Okay, do you guys see where that's coming from? I'm just putting in x plus h instead of using the x. Okay, and then now you're going to simplify this. What do we do with that -3? So -3x minus 3h plus 7, and now that's the first half of the top. Okay, there's no like terms there. You can't really combine anything, so that's good. And sometimes I like to actually just write it out so we can see it. F of x is just -3x plus 7, so I'm just going to write it down. Okay. My next step is going to be to just write out what this is going to look like now. Okay. So f of x plus h minus f of x, and again, I'm writing a little more than you need to, but just for this one problem. I'm just going to do this and put it in parentheses. So that's going to be -3x minus 3h plus 7 minus, and then I'll do the second part and put that in parentheses. That way I don't make any mistakes. And then that's all divided by h. Okay. Does that make sense so far? Now we just combine like terms. This first one, you can just lose the parentheses. There's nothing to distribute. The second one, you distribute the negative. Okay. And now with this, for every single difference quotient problem, it kind of blows up and becomes a hot mess for a little bit, but a lot of things end up canceling. So if you're doing things right, a lot of stuff's going to cancel out and turn into something easy. Do you guys see anything that cancels out? What else? And so what's left? -3h over h, but what's h divided by h? One, yeah. So this is just going to turn into -3. Okay. Do you guys kind of see how to set those up? Okay, I honestly, I don't want to spend, I really hate talking the entire period. This one's a little trickier because there's more algebra involved, but it's the same process. So I'm going to let you guys try to figure that out on your own later on, or just in the homework when it comes up. What I do want to do is finish with these other examples that are a little different, okay? But you'll see that they're actually not too bad, okay? So on this side, we have f of negative 1, and we know that we should get negative 6 for our answer. Here's my rule, okay? The only thing that looks weird about this is that I don't really know what that a is, okay? But since I know that f of negative 1 is negative 6, we can find it, okay? So f of negative 1 just means plug negative 1 into x, right? So if I do that, you get 7 times negative 1 plus a times negative 1 squared, and this is cubed, sorry, plus 6 times x, which is negative 1, minus 4. Okay? And now let's simplify. Negative 1 cubed, that's just going to be negative 1. Multiply it with 7, you get negative 7. Negative 1 squared is just positive 1. So this turns into just 1 times a, or just a. And then you got minus 6 minus 4. Let's combine some more like terms. So that will be, what is that? Negative 7, negative 13, negative 17 plus a. Okay? So when I plug negative 1 into the function, I get this negative 17 plus a. What is it supposed to turn into eventually, though? So what we're going to do now is set it equal to negative 6, because that's what it needs to be, right? So how do you solve for a? Good. Yeah, you just add 17 and you get 11. That's correct. Okay? Did that make sense for that one? This one's similar. Okay? Just a little bit different looking for the function, but same concept. So instead of taking up the time, I'll just end the notes there. And you guys have